Please welcome to the stage Dr. Stuart Young.
Good afternoon, and welcome back from the break. A lot of goodies out there. My name is Stuart Young, and I'm a program manager in the Tactical Technology Office at DARPA. I started my career as a second lieutenant in the Army after I earned my commission from ROTC from the University of Washington, and I also was an engineer at the Army Research Laboratory. I first got started in robotics in the late 90s, where I got the opportunity to work on this program called the DARPA Tactical Mobile Robotics Program. And you might know it better from it created the PackBot robot that's been out there quite a while. As a result of this opportunity, I had the opportunity to develop robotic behaviors myself through the collaboration with that program, including developing a gunshot or sniper detection payload that we used and put on the PackBot. And I realized then it was a great capability, but I realized it was also teleoperated and nearby a soldier. So it initiated in me this passion for developing autonomous behaviors on robots that would allow them to operate further from the soldiers. And then on September 11th, just like many people in the world, my world changed. I was called to active duty as a captain in the Army. And during this time, several of the PackBot robots that I had in my lab were needed for real-world applications in Afghanistan to support looking for terrorists in the caves. And while I wasn't directly involved in the operations, the reports from the field demonstrated the utility of robots. Even one of the robots that we sent over there was destroyed by an IED on a mission. Despite their utility, it continued to fuel my interest in developing robots that could operate on the battlefield with soldiers. The commentary in the DoD at the time was focusing on the dull, dirty, dangerous missions. And while this perspective was interesting, it left me unsatisfied in the fact that the robots were still teleoperated and they were still too close to the soldiers. And I felt that the robots should be able to give us more standoff to increase the safety of our soldiers. So what was needed to meet this need was autonomous maneuver of the robots out in front of the soldiers, not following them. I thought it was crazy that people were thinking that way. And so I wanted to answer the question, how could we get them to operate autonomously? So following my year on active duty, my passion and direction of research became solely focused on how could we get robots to operate in front of our soldiers in a real world environment. It was at this time I really began in earnest working with some of the best researchers in the world, collaborating with them on how to solve this autonomy problem. And I started to learn more the role of machine learning in solving this problem. I had conversations that I still remember vividly today with Drew Bagnell. We talked about the credit assignment problem and how are we going to train our algorithms to be able to deal with that. And my good friend Vijay Kumar at University of Pennsylvania, we had discussions about adaptive control versus learning and how we were going to get after this problem. And then my passion was further fueled by getting to go to the DARPA Grand Challenge as a visitor. I was in the stands at the first event, and I also got a chance to get a behind-the-scenes perspective of what was going on by all the researchers to make that happen. And following the DARPA Grand Challenge, I had the opportunity to do a detailed assignment at the Army's Future Combat Systems program for a couple years. And during this time, I once again had the opportunity to work with DARPA on programs such as Logger, the Learning Applied to Ground Robotics program, and the Unmanned Ground Vehicle Perceptor Integrator program, or better known as UPI, where the Crusher robot, you might have seen some of that. And it demonstrated capabilities that arguably weren't surpassed for at least a decade. And while the autonomy developed in the Grand Challenge and the UPI program were impressive, the system parameters were still largely hand-tuned, and for the specific environment they needed to be focused on, and it wasn't really ready to be deployed by the military. And so in this decade since the UPI program, the DARPA Grand Challenge, the self-driving industry has garnered a great deal of attention and engineering talent, but they're focusing on a different problem that the military faces. And what's needed is to continue development of learning solutions that are more adapted to changes in the environment. Currently, off-road autonomous robots are too slow to be operationally relevant and too brittle to adapt to the environment in which they operate. So this brings me to my racer program at DARPA, where I'm focused on developing high-speed off-road autonomous maneuver in complex environments in which our Marines and our Army soldiers focus. Racer is developing the fundamental capabilities that will enable the next generation of robot combat vehicles by developing and using advanced learning approaches. And here's just a little bit of what we've accomplished in this first year of the program. So if you're interested in working on game-changing problems like those that we're facing in Racer, I hope you'll consider working with us at DARPA to reimagine what's possible and to help us solve the toughest problems that our nation faces. I look forward to engaging with you further at the DARPA timeline at the break. Thank you.